Okay, so before we continue here, I'll just clean up my .cpp file. I'll just clean up my code here for a bit. I want to try and keep each example as self-contained as possible so it doesn't get overly confusing. So again, I'll remove this as well. And we have to keep the super begin play in the begin play. And I think that's about it. This simply sets up those components. And same thing in the header. I'll just go and remove these things here. Initial location and begin play location. Save all. Now what I would like to do is first I'll compile this to see we don't have any errors. So Control B to build that. Okay, so what we want to do in this video is we want to start talking about how we can move objects around. So previously we could use functions to get and set the actor's location. But what if we want to change that over time? We want to add an offset to the actor, and the same with rotation, which we'll talk about in a few videos. Well, that is pretty much what we want to talk about in this video. For now, what I want to do is I want to move the actor each frame just a bit so we can get some movement. Of course, in begin play, you can add some offset if you want to do that, but I want to move this thing like every frame. So what I can do is, you can see IntelliSense helps us here. You can do add actor local offset and so on. So what I'll do is I'll do local offset. We'll start with that to the parentheses. And when you see something like this, it'll look crazy, right? All of these parameters. So you need to pay attention to what is set already. And oftentimes you have a few of these constructors. So what you can see in this first one, it takes an f vector, and the second parameter is set. So we can set that ourselves, but it has a default setup basically. Okay, so you can see the rest of the parameters as well. It has default parameters. You can see where the equals is. So bool b sweep is equal to false, and so on. So we don't have to be concerned with those for now. We will talk about those in upcoming videos. For now, we just want to pass this the location, so where we want this to move basically. And we do that passing in an f vector, and we'll construct this. We'll do 0, 0f. We want to move this in very small increments or steps every frame, and this will now depend on your frame rate. So how quickly this thing is going to move is going to depend on your frame rate. We're not going to talk about delta time and all that stuff for right now. We'll talk about that later. We just want to get some basic movement here. Okay, so add actor local offset. You pass this a vector. Again, you can create a variable if you want, and then pass that variable in. But for now, we'll leave it like this and run to see what this will do. Okay, so we have this actor in the world, an instance of that. This is set to movable and everything like that. So what I'll do is I'll click play and I'll move around. You'll see that it'll move up. It'll keep going up. Next, what I'll do is I'll rotate this slightly. So I mentioned that this uses local offset. That means if I rotate it, okay, you can switch the handle. You can see currently the move handle is positioned to the world axis. Okay, Z is upwards. You can see it follows this world compass basically. If I change that here to the local coordinate system, so local to that actor, you will see that will now change. If I move it like this, you'll see it will follow the actor basically. Okay, so that is the direction that this actor will move in, or should move in, since we've set that to a local offset. Alright, so let's just play, and you can see that is what happens. I have this fun arrow now. Okay, so you can see what will happen if I change that to world. Add actor world offset, and I'll do the same amount. Go back to the engine. Okay, so this should move. So this should move up and down in world space now. Click play. And you can see this doesn't move like a rocket now. It simply moves, keeps moving up. Okay. Well, that is basically the difference between the two. Again, local offset will follow the local coordinate system of the actor, and world will follow the world coordinate system. Okay, in this next section, I want to talk about the arrow component. Now, the arrow component is very useful for visualizing vectors and so on. And instead of doing this in C++, I'll just add it in blueprints because it's much easier. And it's not something that we necessarily want to be, part of the C++ class. We want to keep our C++ class clean. So this is just for visualization purposes. And you can get to this blueprint class again by going in the world outliner and then clicking on edit blueprint. You can see we have my very interesting actor underscore BP open. And from the add component menu, we can look for arrow. So I'll create one, rename that to x underscore arrow. And then I'll duplicate that, create one for y. And if I select one of those, it has a toggle hidden in game. We want to turn that off because we want to see these arrows. We want these arrows to show up in the game. You can also select multiple arrows, and then they have that common toggle or option. And in that way, you can change or toggle that for all of the selected components at the same time. So what we can do is we can duplicate this around. So I have the XYZ arrow components now, and you can see that we have this color option and you have this color picker. So just to do this quickly, the color does not have to be exact. So I just want to quickly grab those colors and I'll rotate these around. So Y, we want to rotate 90 degrees so it faces in the positive direction of Y. And you can see the same thing for Z as well. So pick that color and then rotate that around. And if you're not sure like where the positive direction is, again, we want those arrows to point in the positive direction. You can simply look at the 3D compass, the bottom left corner of that viewport. I'll compile and save that. If I go back to the level editor here and play, you can see that the arrows do show up, but it's a bit small. So what you can do is you can select all of them, press and hold Shift or Control, select them, and then you can go and change the scale. For example, you can click on that lock button, and if you change one, all of those will update. I'll just move my scene around a bit. You can see those arrows are much bigger now. So I'll just move it in place here so it's right in front of us as soon as we start the game. And then I'll click play and you can see this moves up in world space now. And I'll just save this. And so what I can do is again back in the .cpp file under tick, the tick function, I can change this to add actor local offset. And now again you'll see what the difference is. So I'll build and run this. And so if you're wondering what this thing is, again, this is just that arrow, okay, that kind of shows us which way we'll be facing. So if I hit play, that will go away, of course. And now this actor of ours should move up in his local coordinate system as opposed to using this here. Again, it will move like that. All right. Control Z to undo that. So let's hit play and see what happens. As you can see, it moves in its local coordinates. Okay, I'll just move that up slightly. Yeah, something like that. Before moving on, I'd like to talk about these arrow components again. So previously I changed the scale right here, and sometimes I do that, but it actually has an arrow size property right here. Now in some cases, if you change the transform here, that could give you problems. Now in this case, I only have these as children of this mesh component, and that is a child of that root component. Now during gameplay, as we'll see in an upcoming video, we can change this tree structure. So we can have something be a child or something else. So I can move this arrow, for example, and have that be a child of the root component, that scene component, instead of the the uStatic mesh component that it is a child of right now. And when you snap it in that way, so when you make one thing, one component a child of something else, there are various ways of doing that. So you can snap and inherit the scale. So in other words, if something were to be a child of this now, it would inherit the scale and stuff like that. So in those instances, you could have a problem. So for that reason, what I'll do is I'll go. And if you don't follow with what I'm saying right now, don't worry. Again, we'll talk about this in more detail later. But for now, I'll just click on this reset to default arrow. And then I'll go down to the arrow size property, change that to 2, and that should be fine. Okay, and that will change all of those to 2 now, because that is a common property. And I'll just compile and save this and just check that this works. Yeah, that should work. Okay, so just as a quick example, let's say I'll reset this. You don't have to do it on your side. So I'll reset the arrow size for both of these. And then I'll change the scale. So the Y scale, I'll change that to 2 uniformly. And then I'll parent the Z arrow to that. Okay. And you can see it's trying to keep its original scale here. But if I go and reset that, you'll see now it'll have the same size as the Y, even though it's set to 1, and that's because it inherits that scale. And the X I'll just reset here to 1, so we can see in comparison that will be the original size basically if scale is set to 1 and the arrow size is 1. So even though Z is set to scale 1 and the arrow size is 1, you can see it's much bigger because again it inherits that from its parent. If I set the scale here to 2, uniformly you can see it's much bigger now. So again, if you go and change these things around, in some cases you can inherit the scale of the parent component, and in other cases you can specify whether or not you want that to happen. So you want to keep the original scale, you want to inherit the parent scale and stuff like that. You can do that all through either Blueprints or C++. So I'll just undo a few times. Again, my arrow size is 2 and my scale is 1 on each one of these. So I just wanted to demonstrate that. And again, this will make more sense once we get to the attached to component video, okay, where we discuss that. So you don't have to worry about it for right now. Okay, so I'll compile and save again, and this will work fine now. Okay, back in Visual Studio, what I'll do is I'll comment this line out. So we don't want it to move. Later on we'll do a boolean, and then we'll do we want this to move or not. But for right now, just to demonstrate the next thing, what I'll do is I'll show you that we can do something similar, but instead of doing add actor local offset, we'll do add actor local rotation. And you'll see as I type out, IntelliSense helps us here, add actor local rotation. Double click on that and you can see we have these two overloads here. So you can pass in a quaternion, or you can do this one with the FRotator, and we'll talk about that in the section. And then you also have this sweep again. You can see those are set as default parameters, so we are not concerned with those for this video. Okay, so what is an FRotator? I'll just go to the documentation here quickly. An FRotator, you can see, implements a container for rotation information. Now, the rotation values are stored in degrees, and you can see this is a struct, okay, that similar to the effector, you can see FRotator, and then you have these floats, you have pitch, roll, and yaw. And then you can see the add actor local rotation. Again, if you want to see the constructors and you want to see the function overloads, there are, again, a few ways of doing that. You can search the documentation, and you can see it's very easy to see like what the overloads are here. You have one with FRotator, one with an F-quaternion, and so on. And you can also, as I mentioned, you can do that. Just redo that and that will come up again and you can see the overloads. Or you can go to the declaration. I'll just choose one of these and you can see all of these are right here, and you can see the comments. Okay, and that again is in actor.h. What I'll do is I'll do an FRotator. And you can go through these constructors. And so you have pitch, yaw, and roll. If you don't remember what those are, you can go and look at the FRotator. And it explains here, rotate around the right axis, so around Y. And then you have a roll, which will rotate around the forward axis, so around the x-axis. And then we have yaw, which will rotate around the up axis, which is around the z-axis. So we want to do yaw here. Okay, so what I'll do is 0, if, comma, yaw is actually second here. So this is what we want to change. I'll do 1.0 if. We just want to change this by 1 unit, okay, per frame. Okay, so something like this. Add actor local rotation. And you can see right here it's complaining because we have to close this off right here. Okay, so I'll go back and I'll compile this. Okay, one more thing I'd like to notice is if you select the actor, then of course in the transform you have location and rotation. And if you hover here, you can see again roll value, pitch value, and yaw value. So in other words, the axis around which you are going to apply that rotation will show up in here. So if you remember, we put it on yaw, so that is what we kind of want here. So when we play, this should rotate around its local axis. So I'll play this and you can see that's what happens. So it rotates around that. Back in Visual Studio, I'll go to the header and I'll create two more properties. One is going to be bool should move. So should move and should rotate. Okay, so these are properties and I want to set a couple of specifiers for these. So I'll do edit instance only. So for this demonstration, I'm not concerned with exposing this to the Blueprint Visual Scripting. I just want to edit this on an instance basis. So what I'll do is I'll do a category. Something like this, and I'll do the same thing for the should rotate. Okay, in the constructor, I want to set the default values for that. I'll set these to false by default. And I'll go down to back to the tick function. I'll uncomment this add actor local offset. And I'll do should move. So if B should move, actually pressed the wrong key there, so it was bolding. Okay, so another one, the should rotate. So if we have these booleans set to true, so B should move, then we apply that local offset each frame. If should rotate is true, then we apply that rotation each frame. Okay, so simple stuff. I'll go back in Unreal Editor and I'll compile that. Alright, compile is complete. And I'll select that. And if I play, you see this won't move or anything. I'll just select that again. And I'll search for booleans. So should move. Play again, you see it moves. Click stop. And I'll select that again. Should rotate. Enable that. You can see the default. If I left click, that is false. And that is set to false by default in the constructor. Okay, so we enable that, set that to true, and now you'll see this will move and rotate. So just a quick demonstration on these things, and I just wanted to highlight the fact that a Boolean property will show up like this when again you have it set up as edit instance only, for example, or edit anywhere, then again it will also show up in the class defaults. As you can see, you have this toggle here. I'd also like to mention that previously we talked about we can get and set the actor rotation. So that is a bit different than what we have. So here, add actor local rotation, add actor local offset. We have a bunch of extra functionality in these, okay, that we do not have with the other ones. So you can, for example, in the constructor, you can do set actor rotation and get actor rotation and stuff like that. So if you just kind of want to set that once off, then this is great. But these here have a lot of extra functionality. Okay, so as we go along, the differences will kind of become more obvious to you. And you can actually also do, so I'll move up, you can move or apply an offset to some of these components as well. So you can do, for example, root component, and you can do add local offset, add local rotation, and so forth. And we'll discuss some of this stuff in some of the upcoming videos. And in this way, you can move actors like relative to each other in that tree hierarchy, as we'll see again in some of the upcoming videos. And once we start talking about sweeping and all of that, using these functions right here, it'll become more obvious, like when you want to use these. So I hope this video was useful to you.